Hello everyone! We'll talk about Experiment 8, the sieving and liquid limit via Casa Grande apparatus in this video presentation. One engineering laboratory test used to distinguish or group soils into categories is a liquid limit test of soil. When soil is just moist enough for a groove to close when shaken in a particular way, it is at this water content that it transitions from a plastic to a more fluid condition. A clay soil has a shear strength of roughly 2.5 kilopascal when the water content of the liquid limit is reached, according to Arthur Casagrande, who created a standard device for the determination of liquid limit. The standard reference used is ASTM D4318, Standard Test Method for Liquid Limit, Plastic Limit, and Plasticity Index of Soils. Here are the materials and equipment used in this experiment. First is the soil, water, number 200 sieve, sieve shaker, moisture cans, balance beam, oven, spatula, ruler, grooving tool, and Casagrande device.
Next will be the procedure done to conduct the sieving and liquid limit by Casa Grande apparatus experiment. Weigh 3 empty moisture cans and record their respective weights and can numbers on a data sheet. Take a representative soil sample of approximately 120 grams passing through the number 200 sieve and mix thoroughly with distilled water in the evaporating dish to a uniform paste. Remix the soil thoroughly before the test. Place a portion of the paste in the cup above the spot where the cup rests on the base. Squeeze down and spread into position with a few strokes of the spatula as possible, and at the same time trim to a depth of 1 centimeter at the point of maximum thickness. Make a clean, sharp groove using a grooving tool down the center of the cup. The tool should remain perpendicular to the surface of the cup as groove is being made. Drop the cup from a height of 10 millimeters by turning the crank at a uniform rate until the two halves of the soil cake come in contact in the bottom of the groove. Record the number of blows needed to close the gap between the soil cakes. Collect the soil sample and place it in the designated container. Weigh the container plus the wet soil and record its mass. Clean the cup and the grooving tool thoroughly. Repeat the operation specified earlier for at least 3 more additional trials, minimum of 4 in all, with soil collected in an evaporating dish to which sufficient water has been added to bring the soil to more fluid condition. Place all the samples in the oven for 24 hours. Maintain at a temperature of 105 degrees Celsius to 110 degrees Celsius. After 24 hours of drying, take the samples out of the oven and weigh each container containing the dry soil and record the respective weights. With all the data collected, determine the moisture content of each soil sample, and subsequently, you will be able to determine the liquid limit.
So for the data and results of the experiment, in this experiment, we performed 3 trials to determine the liquid limit using the Casa Grande apparatus. To determine the liquid limit, we must know the moisture content and number of blows using the Casa Grande apparatus in each trial. To know the moisture content in percent, the equation that we will be using is mass of water divided by mass of dry soil multiplied by 100. Solving the 3 trials, in trial 1, the moisture content is 29.60% and there is a total of 22 number of flows. In trial 2, there is a total of 24 flows and 28.18% of moisture content. And lastly, in the last trial, trial 3, there is a total of 57 flows and 25.55% of moisture content. These moisture contents and number of flows that we got from each trials will serve as a basis to know the results we got is above, within, or below the liquid limit. The standard number of flows to get the liquid limit is 25. To know the moisture content of the standard number of flows, which is 25, we will use the formula y is equal to negative 0.8153x plus 47.615. Y is the moisture content and x is the number of flows. When you substitute the value of x, which is the standard number of flows, to 25, the result is 27.23%. In the graph shown, as we plot the results of the data we gathered, we can see that the trials we have done is above the liquid limit.
So, the standard reference used in this experiment is ASTM D4318, which is the test methods for liquid limit, plastic limit, and plasticity index of soils. ASTM 4318 specifies the standard procedure for the liquid limit test, which utilizes the Casagrande apparatus. According to our results, the number of flows is inversely proportional to the water content of each trial. We obtained 29.60%, 28.18%, and 25.55% in the 3 trials. After collecting all of the needed data, we determined the soil sample's average liquid limit, which is 27.23%. When enough water accumulates in the soil, it begins to behave similarly to water. Determining the liquid limit of the soil is significant since it provides information on the consistency of the soil. The characteristics of soil activity change as the moisture content increases.